So this is my second example with a Class B address, and this time I'm going to increase the number of hosts to 25. And so I want to create some subnets from network address 172.16.1.0, my Class B address. So each will have 25 host addresses for these following user VLANs, and these are 4 VLANs. Each of them have a variety of desktops, laptops, maybe mobile access devices, a variety of things. And so they're user VLANs. They're not they're for desktops and such. And there's my topology, and there's 4 VLANs, so that means 4 subnets. There's a layer 2 switch, and so it's an easy enough topology. So I want to calculate the subnet mask required for 25 hosts per subnet. So I want to know what that subnet mask is to give me those 25 hosts. So we'll go to my subnetting table, and I'll work over to get to 14. It's not enough, so I have to go to 30 hosts. And what's 30 hosts? Go over here, and that's a /27 mask, and that's 5 host bits. So I'm going to be doing a /27 mask for this example. And /27 means there's 5 host bits here in red, and 3, whatever's left, 3 is available for subnet bits. And so it's so that's the host portion there, and that'll give me 30 host addresses. And the /27 is derived from the fact that there's 4, 8, 16, 8, 16, 24, 25, 27. That's the subnet mask length, 27. So the number of host calculations, starting from the right, there's 5 bits assigned here from the right. So from the right, I'm going to add up the first 5 bits, the values for each bit position, and that'll give me 31, 16, 8, 4, 2, and 1. I'm going to add the number 0, and that gives me 32 addresses, possible addresses. However, there has to be 2 subtracted for the network and broadcast address that are not assignable to a host IP address, to a device. And so that gives me the 30 host addresses, so that'll work for our example. It's a little bit more than the 25, but there's certainly nothing wrong with that. So we'll calculate the number of bits available for hosts, or subnets. So in this case, I know I've got a /27 mask, and that's 3 subnet bits that are available, because if there's 5, 5 and 3 has to add up to 8. There's 8 bits per octet. So the 3 subnet bits gives me a total of 8 subnets available. Or in this case, it would be 8 VLANs, but we only have 4, so there's some room there for scalability, for adding, expansion. So those 3 left bits, I'm going to subnet those, and that's where I'm going to get the subnets from. And for the 30 hosts per subnet, for each individual subnet. So 8 different subnets, or VLANs in this case, because I'm not assigning to a router or layer 3 addresses, interfaces. I'm assigning them to VLANs with a bunch of desktops in them. And I'm assigning 8, deriving 8, or creating 8 from this 172.16.1.0 Class B address with 30 hosts per subnet or per VLAN. So that's what the current situation is with that. And now I need to identify the subnet multiple to assign to subnets. So we know that the multiple is something that's required to do the calculation when we start specifying each subnet, how we're going to assign addressing. So in this case, there's 5 bits for hosts, and these 3 here for subnets. So starting at bit position 6, that value would be 32. That's bit position 6. So just quick reference there. That's the value of it. And so there's 8 subnets available, 0, 32, 64, 96. I'm just adding 32 because it's a multiple. So there's 8 subnets from 0 right through to 224. That's where I'm getting the 8 subnet available to use to use for creating subnet addresses or network addresses. They're synonymous. And step 4, calculate the network address, broadcast address, and host address range per subnet. So here I'm going to start again with the 0 subnet, or you don't have to. I'm going to start with something else, but it's just easy enough to do that. So 172.16.1.0/27 is the 0 subnet, and there's 30 hosts within that subnet that are assignable, and the multiple for the all the subnets is 32. So I assigned 1, 2, and I just made a note here again about how numbers are assigned when I'm starting with a top level address and how I'm going to subnet it. I could have used, as long as they're private IP addressing, unless you want to do public, you can do public, and I'll discuss that more. But these are private addresses I'm working with now, and I could just change the numbers. I've just decided to use 16.1, and I'm going to get 8 subnets. So in this case, I've got the 4 user VLANs, 9 through 12. So 9 is going to get the 0 subnet, 10 is going to get the 32 subnet, and 11 will get the 64 subnet, and 12 will get 96 subnet. And it's easy enough with the previous videos. It's the same process. You start with 0, and then you add 1 through 30, and that's the host range, and then 31, and then so on for each one. And that's basically how that works. All 4 subnets are accounted for. So you've got the host IP address range and network and broadcast address, and that's all you need to define a subnet. And here's just a picture of how I'm going to assign the addresses. And these are the network addresses, subnetted network addresses, if you like, 0, 32, 64, and 96. That's all easy enough. And there's room for adding 4 more because I've got 8 subnets available as well. And so example of the 32 subnet, I'd start out with 172.16.1, and there's the 32. And then if I add 33, that's the first host IP address. I just make that bit 1, and then the next one would be look like that. That would be 2. So I'm adding 32 and 2 is 34 right up to the broadcast address. And that's just an example of how the range works.